Hello, friends. So the topic for today is limiting reagent, our next topic in the series of mole concept. Let's start with the topic limiting reagent. This topic is really important as it not only helps in this chapter, but in upcoming chapters also. So let's study what limiting reagent is. So let us start with the basic concept. In this video, I'll be telling you about what limiting reagent is, the simplest way possible you can understand how to do questions on that, and what are the variety of questions you'll be asked from this topic. So with this, let's get started. So the first topic is understanding what limiting reagent is. So I'll first give you the bookish definition, then I'll tell you in real life how to visualize or understand it. So it is the reagent, that's the definition of it. It is the reagent which gets completely consumed in a reaction. That's it, which gets completely consumed in a reaction. Consumed in a chemical reaction. That is what limiting reagent means. But how do we understand this in numericals and how to do numericals easily? This is the definition. If you have to write definition, 1 mark question, this is how we'll write it. Now let me help you to understand this. Some example of real life example. Suppose you are having a burger making company. Okay. Now to make burger, you need two buns, right? You need two buns. This is the half bun. This is the other half bun, right? And this is the sausage or whatever you're making. Yeah, this is the sausage, right? So you need one sausage and two buns to make a perfect burger. This is the burger. It's ready now. See, just understand in this way. Suppose you want to make a burger and you have two. This is the two bun and this is the sausage. This is the burger ready. Now, if you really want to understand how limiting unit works, let me give a real life example. So let's start. Let's understand. So we understand that we need two buns and one sausage to produce one burger, right? Correct. The question now I'm asking is, if I give you 20 buns and 15 burgers, 15 sausages, then how many burgers can you make? So please solve this question. So pause the video and do it. So I hope you have attempted it. Let's try to understand how we can, solve this. So for two buns, see, for two bread buns, we need one sausage, right? For 20 buns, we will need how many sausages? Exactly 10 sausage, right? That's simple calculation. Two buns, 1, 20, 10. But how many we have been given? But we have been given how many? 15 sausages, right? That means, therefore, we can say that sausages are extra. Or if you really want to make, sausages extra, first thing, are extra or excess, right? Now, but if you really want to use all of those sausages, how many buns do you need? So for 15 buns, so for 15 sausages, we need 30 buns, because for one sausage, we need two buns. So for 15 sausages, we need 30 buns. But how many buns do we have? 20. Therefore, buns are limiting reagent. Simple. So here in this example, bun is limiting reagent, but sausages are excess reagent. This is how you can understand what limiting reagent is. As simple as that. That's it. So now I'm going to replace the same example with some chemistry of substances or chemical compounds. So let me explain it once again. Whenever you have a question of limiting reagent, first understand the stoichiometry. This is the stoichiometry. Then look at the given question. Then try to analyze if this needs this much, then how much would be required for that much. Do a simple arithmetic and you can get the limiting reagent. As simple as that. So let's start with some real life chemistry questions. So the question is, if 20 grams of carbon reacts with 40 grams of oxygen, find the amount of CO2 produced. See, let me explain you one thing here. In this question, why they have given two masses? Whenever you get a question, where two masses are given, you must have a suspicion. Why they have given two masses? Two masses are not really required. See, if you really want to find what is the amount of CO2, if you can go revisit my last lecture, there I've explained that if you really want to find mass of the entire reaction, we don't need two masses. One mass is enough. I'll explain. So first of all, what we'll do first, we'll write the chemical equation. Then we'll balance it. Then we'll write the moles. Then convert the moles to mass. This is something that you have to do always. This is something that I told you in the previous lecture. You can go and watch that. I will be, putting that in the I button over the top. You can go click on the I button and see that video. So 12 grams, 32 grams will give you 44 grams. That is something that we know right now. 12 gram gives you 32 grams. Then 20 gram will give you X and find it out, right? 12 gram gives you 44. Then 20 will give you X. Cross multiply, find it out. We don't really need two masses. Why two masses are given? Yes, it's a trap. So whenever you see two masses are given in a question, you must get suspicious that this could be a question of limiting reagent. Okay, let us take it as X and see for 20 grams of carbon, how much of oxygen is actually required. So let's do the math. For 12 grams, we need 32 grams as per the stoichiometry. Then for 20 grams, how much will be needed? X, right? Let's cross multiply. Let's cross multiply them and see what we get. So we get 12x is equals to 640. So x will be 640 by 12. Let's do it roughly. So we'll get it as 12. If you cancel it out, it will be 8, 4. So 160 by 3. We need something around 53.33 grams. But how much we have been given? See, they got it now. So we need 53.33 grams of oxygen for complete reaction of 20 grams of carbon. So let me go to the next page and tell you what this actually means. For 20 grams of carbon, we need 53.33 grams of oxygen. But we have been given only 40 grams of it. Therefore, what can we say? Therefore, oxygen is the limiting reagent. Simple. Oxygen is the limiting reagent. That's it. This is how we can do it. Now, fine. We got it, like how to find limiting reagent. But what does it mean? Like, how does it going to affect the answer? So let's understand that also. So let's add the stoichiometry once again. C plus O2 giving us CO2, 12 grams, 32 grams, 44 grams, right? Now, whichever is the excess limiting reagent, no? Delete the excess reagent. This is how it works. Once you found out what is the limiting reagent, delete the excess reagent. Okay. And solve the question using unitary method. That's it. Simple. Not a big deal. Meaning, see, look at this here. Which one is the limiting reagent? We just found out that oxygen is the limiting reagent. So this is something I will write here first. This is 40 grams they've given. So this is my limiting reagent, LR. This is my excess reagent. So do I care about the excess reagent? No. As I told you here, delete the excess reagent. So cancel it out. This is not there for us anymore. Erase it. Not useful. Do the question using this. Meaning 32 grams produces 44 grams, then 40 grams will produce how much? X. This is irrelevant now. Cross multiply. So you'll get the answer as X is equals to 32x is equals to 32x is equals to 44 into 4. 44 into 4 will give you 176. 1760 grams. So X will come out to be 1760 by 32. This is the mass. This is the mass. So if you cancel it, it will be, or we can just keep it 44 by 40. It will help in calculation. Yeah. So let's keep it as 44 by 44 into 40. So it will help in. So 44 into 40 by 32. So this will cancel by 10. This will be cancelled by 8. This will get cancelled by 5. This will get cancelled by 4, 11, 2. So it will be 55. So it will give you 55 grams roughly. This is the amount we will get. So 55 gram is the mass that will be produced. This is how we can solve this question and do it in very simple method. So I hope you understood how it can be done and how to actually do questions of limiting reagent. So I'll repeat it once again for those who don't want to have a revision of this. So first you write the valence equation, then you write the stoichiometry, write the given mass, and then write the smaller moles find, and then write the given data. Then just assume one, like for example, 12 gram gives you 32 grams. Just check that for 20, how much is needed. Find it. It comes out to 53. But we have been given just 40. Therefore, 40 is the limiting reagent. Whatever is the excess reagent, erase that. That is going to be irrelevant for us. So delete the excess reagent and solve the question using stoichiometry, meaning 32 grams gives you 44 grams. 40 grams gives us X. Got the answer. I don't care about carbon now because carbon was the excess reagent. This is how we can do it, and this is our final answer. So I hope you got it. Now let me give you another approach on, there could be another type of question that can be asked, which is finding limiting reagent when moles are given. Sometimes they don't give you mass, they give you moles. Finding limiting reagent when moles are given, another variety of question. Okay, so let's start. Suppose it's a question they've given A plus 2B plus 3C gives you 4D. Suppose they give you this question and they ask you that if 2 moles of A reacts with 3 moles of B, and let me write it here. Yeah, suppose if they give you a question like this, if 2 moles of A reacts with 3 moles of B and 4 moles of C, find the amount of D. Find the amount of D produced. Okay, so how exactly we do this question? So I'll give you a very simple algorithm that you can follow to solve this question in the easiest way possible. Let's start with the solution. The first thing is you will write the stoichiometry. What's the stoichiometry? 1 mole, 2 mole, 3 mole, 4 mole, right? Write the stoichiometry first. Then write the given moles as per the question. So 2, 3, 4, right? Now divide this given stoichiometries by the given, given stoichiometry by the stoichiometric ratios. This is given moles. So divide the given moles by the stoichiometric moles. So 2 by 1, 3 by 2, 4 by 3. So what are we doing actually? We are actually dividing these numbers with the stoichiometric moles. These numbers. Okay, so do that please. After that, you will get some values: 2, 1.5, 1.33. Whichever is the lowest ratio, that is your limiting reagent. Finished. Rest are useless. So how to do this question now? So this question can be solved like this: 3 moles, since we got that C is our limiting reagent. C is limiting reagent. So I'll repeat once again: write the given moles, write the stoichiometric moles, write the given moles, divide the given moles by stoichiometric moles, get the ratios. Whichever has the minimum ratio, minimum value will be our limiting reagent. Now erase the excess reagents and then write it like this: 3C gives you 4D, then 4C will give you how much? X. Cross multiply. Therefore X will come out to be 16 by 3 moles. That's how we can solve this question. This is how we can do questions of stoichiometry when moles are given. So we now discussed about 2 topics. finding moles when mass is given, and we just did finding moles when, finding limiting reagent when mass is given, finding limiting reagent when moles are given. Keep one thing in mind: whenever we have two masses or two moles given, understand it's a trap. And it's a trap. You have to think about limiting agent and in such cases. So I hope you understood how to find limiting agent and how to identify the limiting agent, how to proceed with the question, whether it's mass based or moles based. So we'll wind up this video now. In the next lecture, we'll be doing questions and we'll be seeing the applications of limiting reagent. So we'll be doing questions of mole concept, we'll be doing question of stoichiometry and question of limiting reagent together in a video. So I hope this video that we discussed about the topics are cleared. If you like this video and if you think that it is useful, please share it to your friends. Like the video, subscribe to my channel. Thank you so much.